The Brenner Pass is frequently associated with more than two traffic bottlenecks. Every year, 50 million tons of cargo, 5 million trucks, and 14 million cars use this road along the Austria-Italy border. When someone gets caught in one of these traffic jams, their only thinking is probably, when am I? As I finally arrived at my destination, I must say that the Alps are breathtaking because the pass passes directly through the center of Europe's main mountain range. However, begin transportation situation in this area. Some good news for stranded traffic and businesses that have been waiting ages for their cargo. 1,900 feet below the Brenner Pass, a huge infrastructure project worth. We just need to wait for the construction to be completed before we take a closer look at what's happening in the Alps. Back in the day, people were constantly considering the simplest way to get from Central Europe into modern-day Italy. A project worth over 8 billion euros is currently under construction that is set to drastically alter the area, because the well-known European Alps were nearby. Fortunately, geological processes created a single pass that became known as the Brenner Pass. Note, this isn't the ideal mountain route that runs flat with the landscape before entering the Alps. The pass's highest point is 4,500 feet, and because the route's layout. Although the terrain is reasonably easy to traverse, the Brenner Pass was constructed a long time ago as the primary route connecting Central Europe to the southern region of the Apennine Peninsula. However, as European nations continued to develop, their populations increased and trade reached previously unheard of levels, necessitating the need for In the late 1850s, a railway line was successfully constructed through the Brenner Pass. The road for wheeled transportation also needed to be replaced, and in 1971, this is exactly what happened. A highway was constructed across the pass, with the Austrian portion known as the A13 beginning in Innsbruck at the Brenner Pass, where it merges with the Italian A22 and heads into. The two existing routes in the southern part of the country were well liked by everyone because they allowed people and goods to travel quickly from Austria to Italy. However, as the states continued to develop, the amount of trade continued to increase. It should be noted that the Brenner Pass is not only used for trade between Austria and Italy. Goods from all. Traffic from 1970 to 1999 increased from 3 million tons to 22 million tons, more than 7 times as much. The increase in trade was so significant that in 1990, 70% of cargo from Eastern Europe was transported by rail, with the remaining 30% being transported by trucks on the highway. Why did people begin to prefer this method of transportation? Road transport is more flexible than rail, even if we ignore the fact that the latter option is more flexible. The mountain railway has tight curves and a maximum gradient of 2 because the railway line was constructed in the 19th century without any real consideration for the significant increase in freight volumes. In this instance, the gradient isn't very high, but it's still sufficient to lower the speed to 43 miles per hour and the load that the locomotive can carry. By the way, 6% is a significant problem in freight transportation. Without getting too technical, the steeper the gradient, the less the locomotive can pull. More trains don't really help. On the one hand, Italy finished upgrading the railway line in 2008, which theoretically permits 240 trains per day to pass through the Brenner Pass. However, nothing was done to improve the gradient, and there's also the problem that Austria uses a different electric system than Italy's. First, trains must stop and change locomotives. In recent years, using multi-track rolling stock that can run normally on both sides has been proposed. However, there is also the requirement that locomotives carry specialized equipment for different systems, have permits, and need skilled personnel in general multi-track operations. Perhaps they could employ road freight instead of rail, as it is now limited in practice. Another issue is that the number of trucks crossing the pass by vehicle is increasing in tandem with the population of Europe. In 2004, for instance, there were just 1 truck moving through the pass. 8 million, and by 2024, that figure has already increased to 2.5 million, but 14 million vehicles traverse the route annually, and 50 million tons of cargo flow through the mountain pass annually. In 2023, Austria sought to address this problem, and the Tyrol region implemented limitations. The minimum number of trucks permitted to cross from Germany was reduced to 300 per hour. However, the restrictions did not alleviate the traffic congestion, which could extend up to 43 miles. Nevertheless, people were aware of the delays in cargo while they were stuck in traffic. Since the Brenner Base Tunnel, or BBT, has been under construction for more than 10 years, since the first stone was laid in 2007 and drilling work started at the construction site near Innsbruck, Austria, transport across the Brenner Pass would improve. However, this is not the end of the tunnel's construction. We have an 8.3 billion euro project, and in such a vital location, they only began drilling the pilot tunnel beneath the Alps in 2007. By 2009, they had finished the first section, and important details about the rock formations and other details were acquired, which served as the basis for the construction of the main tunnel. According to the plan, the pilot tunnel will be required for drainage and upkeep of the main neighboring tunnels. The tunnels will be 34 miles long and roughly 26 feet in diameter. One train will travel towards Italy and the other towards Austria, and 4 side access tunnels will run alongside them. If the 2 main tunnels and the rock aren't enough to make the Alps resemble an anthill, the project will also include 3 emergency stations every 12 miles and every 1,100 feet. These tunnels will run the length of the BBT, which rises to the surface and permits the loading and unloading of soil and materials. That will serve as evacuation routes and shelter for passengers in case they need it. After passing through the layers of alpine rock, the BBT will eventually be 5,600 feet below the surface, making it one of the world's deepest railway tunnels. However, there is also the tunnel's highest point, and that's where things get interesting. Right on the border between Austria and Italy, the current plan is approximately 2,600 feet above sea level. Why is this necessary? Well, it will allow Austrian water to flow into Austria and Italian water into Italy. As you can imagine, digging tunnels through rock is a difficult task. But these days, tunnel boring machines are helping. Thus, who do you think they go to for boring tunnels for the BBT? Of course, Germany and Heron Connect, whose logo appears in practically every video where we discuss tunnels. It's interesting to note that Heron Connect supplied not 1, not 2, and not even 5 machines, but 8 as of 2024, each of which is a giant with incredible power that has made the drilling process much faster. One of these is the Gripper, a moving object that is about 650 feet long, weighs 1,800 tons, and has a diameter of 26 feet. It was constructed in 2015 inside a mountain cave and began drilling a specific 10-mile section of a tunnel from Marino in Austria to the. Another machine in Virginia began tunneling in the early summer of 2019 and set a record for mechanized tunneling in 2021, completing its work at times in 2020 when it reached speeds of over 200 feet per day. The record-breaking machine was able to complete its task by 2023, you could say. As you can imagine, when tunnel boring machines dig a tunnel, they produce a lot of crushed rock that must naturally go somewhere. These are brilliant solutions for the BBT project that were developed and delivered by Heron Connect, but the German manufacturer doesn't see it that way and calls another of their solutions genius instead. The entire project would simply come to a complete stop after the first few hundred feet of exploratory tunnel. Yes, the project machines have a system that moves all of the resulting sludge along the body to the back, but that waste must also be disposed of. In the meantime, the project's total amount of rock that will be removed is approximately 742 million cubic feet in size, and it cannot be thrown away. Part of the sludge will be used to build access roads, and the remainder will be used for the tunnel's concrete lining. Her clever solution is to connect the enormous conveyor belt system that the company developed, which has a nominal capacity of up to 5,000 tons of. If there were no system, 190 trucks carrying a 26-ton load would leave the tunnel every hour to handle the removal and transportation of all the extracted material, according to the Heron Connect company. In that scenario, traffic jams would occur during the tunnel's construction, which is meant to relieve traffic in parts of Europe. Everyone is satisfied with what Heron Connect has done thus far, even though it may seem like everything is going smoothly. The BBT route passes through 5 different types of rock and one of Europe's longest fault lines, so tunnel. Boring machines by themselves won't cut it. In addition, roughly half of the project's tunnel construction is completed by machines, with the remaining 50% coming from very basic, low-tech methods of drilling and blasting that have been used to dig tunnels for hundreds of years. Explosives are loaded into pre-drilled holes and then detonated. It's a little more complicated than using tunnel boring machines because the loose material is first removed using heavy machinery and conveyor belts, followed by the use of shotcrete to stabilize the tunnel surface and the installation of anchors, mesh arches, and reinforcement mats for structural support. Machines move the reinforcement through the rock, but it seems that in alpine conditions, explosions are unavoidable. When the 34-mile tunnel is completed, it will rank 3rd in length among all railway tunnels worldwide. The Swiss GDD-based tunnel, which is 35 miles long and also constructed in the Alps, will be longer than it. Mount Diamond-based tunnel, which will be 36 miles long when finished, is also being constructed in Europe's main mountain range. Yes, the Alps are the epicenter of railway tunnels, but the new tunnel will at least make people proud. At most, it will increase traffic between Austria and Italy. The BBT is a tunnel that was carefully designed to run nearly horizontally. The maximum slope will only be 4 to 7%, which allows freight trains to pass through Brenner. First, let's keep in mind that the feature of the rail track through the pass with its incline greatly worsens the state of trade that requires locomotives to pull more than twice as much weight, which greatly increases trade efficiency from the beginning. However, because of the slopes, trains passing through the pass typically travel at a speed of about 43 miles per hour, as is claimed because there isn't a steep incline and the generally more modern design but will allow trains to travel at 74 miles per hour. The current 2-hour journey from Innsbruck to Balsano will only take 50 minutes. I think it goes without saying that this is fantastic for trade and all those millions of tons of cargo, but the advantages extend beyond trade. The BBT will not only be a tunnel for transporting goods, but also a road that allows. Indeed, we are discussing passenger trains, which are extremely helpful considering the growing number of European countries and the increasing number of tourists traveling between the south and other parts of Europe. In terms of passenger transportation, the tunnel will outperform the cargo one with travel speeds reaching 155 miles per hour, and let's not forget about traffic jams. The Brenner-based tunnel's opening will lessen their number, which will undoubtedly please many people because driving through the tunnel is more convenient, quicker, and therefore more economical. Since the tunnel has no slopes, many businesses will choose the BBT, freeing up the highways from trucks that are frequently the reason behind the traffic bottlenecks at the pass. Many people may decide to take the train through the tunnel instead of driving through the pass. Yes, they will have to forego the breathtaking views from the mountain road, but the trip will take less time. Oh, and we forgot to mention that there are a lot of cars at the pass. Frustrates people not only because of traffic bottlenecks, but also because of air pollution. The problem is that Austria's regulations were designed to reduce noise and pollution in addition to the number of trucks. Now that BBT is likely to assist with this, Austria can likely be entirely satisfied. The only thing left to do is wait for the last estimated completion date is 2032. In addition, there is another less evident benefit that BBT will offer. It will enable much faster travel from Finland to the Mediterranean on a single route. The 34-mile Brenner-based tunnel is only a small portion of the massive Helsinki-Valletta or ScanMed. In other words, in addition to the BBT, it also includes the Färn Belt Fixed Link, an 11-mile underwater tunnel that spans the Femern Strait between Germany and Denmark and costs over 7 billion euros. This 3,000-meter route is a mega project within a mega project worth tens of billions of euros. Be finished in 2029. A smaller but no less interesting infrastructure project has been proposed spanning the Messina Strait between Italy and Sicily. It will be a suspension bridge that is 12,000 feet long and 1,250 feet high. If it proceeds according to plan, it will be the longest suspension bridge in the world. Construction was supposed to start at the end of April 2025, yet, as of May of this year, there have been no updates regarding the start date. This is generally not surprising, as the most recent estimates indicate that it will cost 13. In fact, the local public is opposed to 5 billion euros, which is more than the cost of each of the ScanMed tunnels presently being built. Construction professionals feel that national and European funding should be used more wisely rather than on a project that lacks all the required hydrological, seismic, and landscape studies. It's uncertain when construction will begin or even if it will happen, but they assured, completed by 2032, if that's the situation. After 2032, there will be a chance to travel in style from Helsinki to Valletta, traveling through a number of multi-billion-dollar mega projects in the process.